Hello everyone, welcome back to this tutorial whereby today I'm going to talk about three major things that will guide us in our journey of programming. One, I'll talk about algorithm. Two, I'll talk about flowchart. Three, I'll be talking about pseudocode. Those are the three things I want to focus on as we move on. So I'll start with algorithm because we practice this in our daily life every day, and there are different types of algorithms. So an algorithm, let me say an algorithm can be simple, or complex depending on what you achieve. You get, depending on what you achieve. And same, an algorithm is a sequence you remember sequences in primary of finite steps to solve a particular problem. Yeah, so an algorithm, let me first reduce my size, edit an algorithm, set it to, I think I set it to 30. Okay, back to 40, 30. Okay, so they say an algorithm is a sequence of finite steps to solve a particular problem. For example, to say I have a problem of taking tea in the morning. You get? So this problem, I'll say I have a problem, I want to take tea. Fine. So if I want to take tea, my algorithm will have a start point and it will have an end point. An end point will be where I'll be drinking tea, and a start point will be where I'll be making tea. So I will say, since it's a sequence of finite steps, I will say step 1, go to the kitchen. Then my step 2, I will say get a kettle. Step 3, I will say after getting a kettle, pour in cold water. You get? After pouring in cold water, I'll say light the gas, or depending on what I use, put on electricity. Say I will say after the water boiling, I will say get a cup, add in milk. 6, I will say drink tea. So that means here, okay, in an algorithm, I might skip other steps depending on how I prepare my things, but here this will be my start: going to the kitchen, having this problem, so I have to solve it, and then it will be solved here by taking t. That is an algorithm. So if you're going to program, you have to first think of an algorithm of what you're going to do. For example, I'm told to find out if you will do this as an assignment. Find out the number the number entered by the user is a positive or negative. For sure. So if I have like this, it's a program, I want to write down an algorithm of it. I will say what I have to first know is that I have to know positive numbers. Positive numbers, if we use the number line, I can say consider that the natural numbers 1 to 9, they are positive. I don't know whether 0 is included. And negative, so to say this is 1, 2, 3, 4, 5, 6, 7, 8, 9. These are positive. And I say negative 1, negative 2, negative 3, negative 4, negative 5. Those are negatives. So I have to know what are positive numbers, what are negative numbers. So after knowing this, I'll tell a user 1, enter a number. Then I'll check the number. 2, I'll check the number. Check the number whether it's positive or negative. After checking, then I'll report. I'll say the number is positive. So here there is a step. I've told the user to enter a number. Or I can say 1, choose a user. 2, enter a number, check. The number is positive. If he entered the positive number, that's say he entered 5, 6. You get? That's what we call algorithm. So even there are many algorithms in our daily life, like crossing the road. You first check the left, right. Is the car coming? Yes. Stop. Has the car passed? Go. Traffic lights. It's also a daily life algorithm. The traffic lights, whereby you see when it's green, you move, red stop, yellow get set. So in everyday life, we go through algorithms, and there are various types of algorithms. There are various types of algorithms. Yeah, we have one. It's a brutal. I'll talk about them in next chapters. A brute force. We have a recursive. 2. Recursive. And 3, we have backtracking. Then on our 4, we have search. On our 5, we have sorting algorithm. We have hashing. On our 6, we have hashing. On 7, we have divide and conquer. It's also an algorithm. Then you have another one which is called greedy. Greedy algorithm. And we have another one called dynamic programming algorithm. Yeah, dynamic is number 9. It's dynamic dynamic programming algorithm. Depending, you use these algorithms depending algorithms depending on the system you are to work on. So that was about the algorithm. So just know in daily life we go through algorithms every day, making tea, becoming hungry, and you want to eat food. Yeah, such things. So now let's look at a flowchart. Yeah, let me clear this. Yeah, when we talk of flowchart, a flowchart is a diagram. Okay, let me start like this. Flowchart is a diagram or diagrammatic way that represents a workflow process. So this flowchart mostly is used by software developers. They use it to see how the system will flow, because at first they have to have the algorithm how the system will work. For example, we have an algorithm whereby we have to capture marks of students, then they will put it in diagrams, diagrammatic way to present. It's very crucial. At times I use Microsoft Visual. So a flowchart has different shapes to use. We have a start, we have to stop. I will show them to you. We have a process. Sorry, 3, I'm disorganized. We have the process, then 4 we have a decision box. Then we have 5, we have the arrows. So let me open my Microsoft Visual. Yeah, Visual 2016. We see where what is. When we open it, there is basic flowchart. Let me select there. I can start with this, but I can create mine. So if I happen to create, I will say this is a process, this is a decision box, this is a start, sub process, and data. You read more about them. So to say, if I'm going to solve a problem of making tea in the morning, so I'll need to have all these flow chartings. So I'll be like this will be my start. It will be my start. It will be my start. You see, on my start, I'll say I'm going to make tea. I start from there. So I will choose an arrow that I will be. I will choose an arrow. Why is it disturbing me? I'll make it straight. Okay, let me just do like that. This will be the process, but it has to be straight. It will be the process. So the process will be edit. The process will be I want to make tea. I want to make tea. Then the fonts are small. I want to make tea. From there, I'll add another process box here. I'll add another process box whereby I'll be prompted to take to get a kettle. Yeah, I'll connect this. Okay, we shall see more about that, but let me use this image to bring out the clear thing. We'll talk about it more. So I'll use this. So here they will say start. I'll start. I say put water in the kettle. It's a process. Put kettle on a boil, like electricity weight. So from there we'll go to the decision box. Has the water boiled? If it's no, I wait for 5 seconds for it to boil. So I have to go back to the one step back. I'll have to go back one step to wait for the water to boil. If the water has boiled, I'll have to go to another step. That I'll put my kettle on, I'll put in water, it's on, I check whether the water has boiled. If it's not, I go back to that one step back. So if it has boiled, I go in, put a tea bag in a cup or a mug. From there, I'll add water that has been boiled. Okay, this one has an error. So the process, leave 5 minutes to boil here after putting in the tea. Then I will say this had to be it had to be put water in a mug, not boil. So from there I will say I want sugar wanted. If yes, I add in sugar to a cup. If no, I process to another step because I don't need sugar. So I go, is milk wanted? If yes, I add in milk in the cup. If no, I go to another step. For example, if I need to cool it, I go down until I end my pseudocode. Flowchat. So this flowchart is vital in our process. Then we have what we call pseudocode. Pseudocode is more of a program but written in an English form of language. For example, I want to find out whether the number is odd or even. I will say, if I'm trying it's also steps. I will say enter num1, num2, enter number. Okay, let me say enter number 2. I'll go on and say, to know whether the number is odd or even, it has to be divided by 2 and the remainder is 1. The number tends to be odd, 0 even. You get? If the modulus of a number is 0, that means the number is even. So we say number modulus 2 and returns 0. The number is even. And then I can say if the modulus, if number modulus 2 is equal to 1, the number is not even. Okay, anything, but that will be the pseudocode. So the major difference between the three they do the same thing. A flowchart is need, an algorithm is needed while we are doing our programming, and it's vital. You can never do anything in programming if you don't know what you're going to tackle about. For example, I can start writing a program that will test whether a number or a grade entered, or a marks entered by a student or a teacher. Oh, sorry, let me use this example. If I want to know whether a person has passed or failed, I have to be knowing the grades from A, B, C, D, E, and fail. That every above 90 award A, 70 and 80 award B. So if I don't know that, trust me, I can never develop that program. So I have to be knowing all the steps, and these things are very vital in our programming. So once you relate to the daily life of solving a problem, that means you can solve more problems, and you can work on more